Welcome to this video. I'm Zhang Xinyi, and in this video, I would like to introduce my FYP project, GDCEngine, an end-to-end machine learning engine for green data center control optimization with digital twins. Here is the table of contents of today's video. I'll firstly give a big background, then talk about existing problems that motivate this project, followed by the design and case study of GDCEngine, and in the end, I will wrap up the video with a conclusion. Let's get started. This project is about data centers, which are dedicated buildings to house computer systems. They are the backbone of the internet. So in recent years, as the internet industry blooms, the DC market has been expanding rapidly in order to meet the rising demand for cloud services. The growth is even further accelerated due to the surging number of online activities brought by COVID-19. According to the latest report, the global DC market is predicted to have a compound annual growth rate of over 13% in the coming years. However, along with the great economic value, the growing market has also brought concerns to the increasing electricity consumption of its supporting infrastructure. The latest statistic in 2021 shows that 7% of the total electricity demand in Singapore is consumed by DCs, and it has been forecasted that the global DC electricity demand will double by the end of this decade. Therefore, it is important to improve the energy efficiency of DCs so that we can have a sustainable future. To save energy, we firstly need to know how it is consumed. Here is a pie chart, and we can see it's mainly about IT power and cooling power. IT power are consumed by computing hardwares, and is considered necessary and do not have much room to be cut down. However, on the contrary, cooling power depends heavily on your cooling control policy. Data centers nowadays normally use feedback controllers to maintain the room temperature, which does not optimize the energy consumption. Therefore, recent studies proposed ML-based cooling control policies. They are mostly deep reinforcement learning, or DRL in short. They are considered effective and can save 10 to 20% of the total power through experiments in laboratories. However, despite them being so promising, little of them are actually deployed in the real world due to safety reasons. As DRL essentially utilizes deep neural networks, due to the nature of them, it may have unregulated and unpredictable behavior. In our scenario, it may issue undesired cooling commands that lead to thermal safety issues, for example, overheating that burns the hardware. Such a character is fatal. To mitigate the impact of this character, DC simulation software might be a good solution. They can be used to mimic the real DCs with no safety costs, so that we can get the DRL prepared before its deployment as much as possible. However, current DC simulation softwares are not designed for ML training. They are designed for building professionals and require large amount of civil engineering knowledge. Such software is unfriendly and difficult for ML researchers to use. And yet, perpendicular to the problem of AI itself and the simulation software, little attention has been paid to transfer state-of-the-art AI from laboratories to real DCs for daily usage. The adoption of AI often faces difficulty as the DC operators are mostly not trained machine learning professionals. Such a neglected last mile slows down the AI transformation of today's DC management and operation. Therefore, in light of such problems, we propose Green Data Center AI Engine, or GDCEngine in short. It is an end-to-end platform for green data center ML research and application. It synergistically combines an ML researcher-facing multi-physics DC simulation platform, a set of trustworthy ML-based cooling control policies, and a DC operator-facing ML training web platform. Or in short, GDC Simulator, GDC Policy, and GDC Portal. Here is the high-level architecture of GDCEngine. The three modules are loosely coupled to allow for flexible workflows. GDC Simulator is the bottom-level infrastructure that is required in every major use case, and the ML-based algorithm module GDC Policy can operate on top of it via the front-end module GDC Portal. These modules are supported by related open-source tools such as Docker, Tianshou, and OpenAI Gym. We provide two interfaces that accommodate different user groups. Next, I would like to demonstrate how GDC Simulator and GDC Portal can serve ML researchers and DC operators respectively in their own ways. For GDC Simulator, you can clone the repository and run this one-line command to set up everything for you via Docker. You can also pull our public image so that you don't have to build locally. After setting up, we can create a folder under Models, which represent our data center. In this folder, we put the DC modeling file obtained from building professionals. It is a standard modeling file that does not contain any ML-specific information. After that, we create a folder under experiments to store the configuration and our experiment scripts. The simulator will by default look for a configuration file named engine.prototext, and we have other util class to help you write this configuration file automatically so that you don't have to do everything character by character. For example, here we are having a utility tool that scans through the modeling file and suggests you on the possible actions and observation configurations. You can copy and paste into your own configuration file. After completing it, we create an entry script under the experiment folder to initialize the simulator. Here I'm going to show you how GDC Simulator can easily be used via just a few lines. So with this one-line command engine.init, the engine is now ready to be used. The return environment follows the OpenAI Xinyi interface, so it can use pretty much every third-party algorithm collections to interact with it. After completing the script, you can run experiments via just one line of command in a shell. During the experiment, you can monitor the status of data center through the cloud database. Or alternatively, you can also use our utility tool to profile the local logs as shown here. After showing GDC Simulator, here is a prototype for GDC Portal, where DC operators can use to train models in a self-help way. As you can see, the training configurations are intuitive and easy to understand. We also designed a page for A/B testing, where you can choose controllers and compare their performance, so that you can have the better one to be deployed. After the demonstration of GDC Simulator and GDC Portal, I believe now you have a better understanding on how GDCEngine could be easily used. Perpendicular to that, I would like to show how GDCEngine could help save the energy in a safe manner via a case study. Our target data center has a single data hall and a chilled water cooling system. It is located in tropics and has demanding tasks, which means its IT utilization is very high. We compare several approaches. Firstly, industrial common practice, which is a baseline, and 3 ML-based policies that are in the literature. And finally, methods from GDC policy, namely Safari 1 and 2. Experiments are conducted with GDC Simulator. The policies are firstly trained for 50 days and then evaluated for 1 year. Diagram A, B, and C reflects the statistics during the training phase, namely reward, violation count, and violation magnitude in terms of thermal safety. We can see that both Safari 1 and 2 achieved high rewards and lower violation magnitudes. Safari 2 produced the minimal violation counts. Diagram D and E reflect the statistics during the 1-year testing period. We can see that both Safari 1 and 2 achieved a lower total power compared with the baseline, and they can maintain the room temperature within a proper range. All these statistics shows that GDC policy is trustworthy in terms of energy saving and thermal safety awareness. It has the potential to be easily used by DC operators to apply in their own scenarios. With that, we are coming to the end of this video. In this video, we presented GDCEngine, an AI engine specialized in DC cooling control optimization. We showcased several characters of it through examples, demonstrations, and case studies. All in all, GDCEngine is a firm step towards transforming green data center machine learning research and application. Together, we can make a sustainable future. I hope you liked this video, and thank you so much for watching.